Today's workshop is on the topic of probability. Today's intent, we're going to be looking at understanding and expressing basic probability, writing probability on a scale, expressing probability as fractions, decimals and percentages, understanding and calculating combined probability in both tables and trees. So first, what is probability? So probability is the likelihood that something will or won't happen. So for example, the chances of it raining in England, the chances of snow in the Arctic, and the chances of winning the lottery. The higher the probability is, the more likely it is to happen. And we can express probability as words. So for example, the words certain, likely, unlikely, impossible, even chance. And it can also be expressed as a fraction, a decimal, or percentage. So the easiest way to look at probability is to write it as a fraction. So we say at the top of your fraction is the number of successful outcomes, and at the bottom, the total number of outcomes. So for example, here we've got 5 cubes, 2 white, 1 orange, 1 blue, 1 grey. So there are 5 cubes altogether, so the total number of outcomes would be 5. So if we picked out a cube at random, the probability of getting a certain colour is white is 2 out of 5, blue is 1 out of 5, green is 0 out of 5. And the reason why it's 0 out of 5 is because there's no probability or no possibility that there will be a green cube that we pick out, and orange is 1 out of 5. So if we're given the probability of something happening, we might be asked the probability of working out something of not happening. So there are 5 out of 5 chances altogether. So if the chances of getting a white cube is 2 out of 5, the chances of not getting a white cube will be 3 out of 5, because your will and won't happen likelihood must always add up to a whole or 1. So 3, 2, 5, 5 and 5 is a whole. So what are the chances of not getting the following colour? Orange. So the chances of not getting the following colour. So the chances of getting it would be 1 out of 5. So the chances of not getting orange would be 4 out of 5. Okay, what's the possibility of not getting grey? What's the possibility of not getting grey? So the probability of getting grey would be 1 out of 5. So the possibility of not getting grey would be 4 out of 5. And then finally, green. What would be the probability of not getting green? So the chances of getting green would be 0 out of 5. So not getting green would be definitely certain, because green's not there. Okay, the first element of probability that we're just going to look into a bit closely is probability scales. So a probability scale is a line that marks the chances of an event happening or not happening. So as you can see, 0 at the very bottom is impossible. And as we go up each part of the probability line, that probability increases to certain. So we have impossible at 0, even chance halfway, and certain at 1. We then have likelihood, so unlikely to even chance between 0 and a half, and then even chance to certain at likely. So the top tip to remember, the amount of lines after the 0 tells you what the probability is out of. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our probability is out of 10. So we might be asked to show probability on a scale. So there are 5 cube and 1 mark scale represents 1 cube. So here each line does represent a cube. So we have 5 lines. The chances of getting an orange cube would then fall at 1 out of 5. And the chances of getting a white cube would fall at 2 out of 5. So then what would be the chances of getting a green cube? Where would that be? What would be the possibility? And you're right, it would be impossible. Brilliant. So Ahmed has 20 sweets. 4 of the sweets have no wrapper. He picks a sweet at random. On the probability scale, mark the probability that the sweet has a wrapper. So what's really important to establish before we look at the scale is 4 out of 20 equal no wrapper. So then how many have a wrapper? So we're going to do 20 take away 6, 20 take away 4, which is then 16 out of 20 have a wrapper. Okay, now let's have a look at our scale. So our scale, let's have a count. 1, 2, 3, 4, 5, 7, 8, 9, 10. Our scale is out of 10. But our fraction is out of 20. So what we need to do, a little bit like fractions and simplifying, we've got to get our denominator to 20. So we do that by dividing by 2. And we can do the top divided by 2, which then gives us 8. And that is our probability of it having a wrapper. So now that we've done that, we can then plot it. So 1, 2, 3, 4, 5, 6, 7, 8. So the probability of having a wrapper. So it's very likely. Hey, let's have a go at some of those. So we've got our probability as 4 out of 20, and then we've got to mark whether it is certain, likely, impossible, unlikely, unlikely. So actually it's going to be impossible there and impossible there. Okay, so let's count our lines first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know our probability is out of 10, but our fraction's out of 20. So what have we got to do to 20 to 10? We've got to divide by 2. We do the same to 4. So our fraction is 2 over 10. We're now going to count 1, 2. There's our probability. And then that falls in unlikely because it's between impossible and even. Okay, let's try our second one. So we've got 12 over 20. Same. So it's got to try and make it 10. We're going to divide by 2 again to both sides of the fraction, which leaves us with 6 over 10. 1, 2, 3, 4, 5, 6. We're going to go here, and that is more likely. So it's all about making your fraction match the amount of lines that are on our page. Okay, what we're now going to have a look at is expressing probability as fractions, decimals, and percentages. So when expressing probability, remember the top number is the outcomes that you're looking for, and your bottom number is the total amount of outcomes. So if there are 10 sweets in a bag and 3 are green, the chances of picking a green sweet are 3 out of 10, because that's what you're looking for in your question. And then this is the total. Always your bigger number is going to be at the bottom with probability. So to change fractions into decimals and percentages, you do the following. To turn a fraction to a decimal, you divide the top by the bottom. And to turn a fraction to a percentage, you divide the top by the bottom, then times 100. Now, sometimes these can fall on both the non-calculator and the calculator. So the way that we're going to do this is for non-calculator, we're going to use bus stop method. So what is 2/5 is a decimal and a percentage. Okay, so 5 goes on our outside and 2 goes inside as a decimal. So 5's into 2 doesn't go. Carry your 2 over. 5 into 20 goes 4 times and a 0. So our decimal is 0.40. And then our percentage, we're then going to do 0.40 times by 100. And we're going to be left with 40%. So we want to try and get comfortable with doing it without a calculator. So then when it comes to a calculator paper, you can do both methods. Okay, so let's have a look at this. There are 30 children in a nursery and 4 have brown hair. What's the probability of a child in the nursery having brown hair? Give your answer as a fraction in this lowest form. So now we're going to use our skills from fractions to simplify. So the amount that we're looking for in our question is 4 and our total is 30. Okay, so we've got our fraction. Now we're going to simplify it, and both can be divided by 2. So we're going to do 4 divided by 2, which is 2, and 30 divided by 2, which is 15. And we cannot simplify that anymore. So our fraction and our probability of picking a child in the nursery with brown hair is 2 over 15. Okay, let's try B. A nursery manager is playing a game with toddlers. She spins a spinner with numbers from 1 to 6. What is the probability on a number less than 3? Give your answer as a fraction, as a percentage. So now imagine we're counting our numbers from 1 to 6. And how many are less than 3? So not 3 or less than 3, we've got 2. So our fraction is 2/6. And if we simplified and divided by 2, would be 1/3. Now, to get it to a percentage, we need to divide it by the top by the bottom to get it to a decimal, and then times by 100. So we're going to put 3 on the outside and 1 on the inside. 3 into 1 doesn't go. 3 into 10 goes 3 times with 1 left over. And we're going to have what's known as a recurring number. Now, if we then put that and we times that by 100, we're going to be left with 33.333%. We always want to give to 2 decimal places. So using our rounding rules, it's going to be 33.3. That third 3 is going to keep that one as it is, so that's going to stay at 33.3%. And that is our percentage. Right, we are now going to look at the last 2 elements of probability, focusing first on probability tables. So with a probability table, all your boxes add up to your total. Sometimes you might be asked for one specific thing in a probability table. So if you were asked for girls, you would look at the girls column. If you're asked for boys, you would look at the boys column. If you were asked for looking at children that are younger than 3, you would look at this column. And if you were asked for children older than 3, you would look at this column. So an EYFS teacher wants to know the likelihood specific ages of children in her class. There are 20 children in her class. Complete the table above. So we know that the total is 20. So we must add all of these together to make 20. So we're going to do 5, add 4, add 7, which is 16. We then know that something added to 16 makes 20. So 20 take away 16 leaves us with 4. So now we've completed our table. Now we're going to look at calculate the probability that picking a child that's female and younger than 3. So we need to look at girl, female, younger than 3 is 4. How many is it out of in total? 20. So 4 out of 20. We then can divide both by 4 because it's always good to simplify, which leaves us with 1/5. And that is our second question. Then we're going to be looking at calculating the probability of picking a child that's older than 3. So now we're looking at the entire column older than 3, which 7 add 4 is 11. So it's going to be 11/20. And we want to give our answer as a percentage. So this time we're going to have to put it in bus stop. So 20/11. 20 and 1, 0. Carry the 1, 20 and 11 got 0. So now it's going to be 110. So how many 20s is in 110? Which would be 5. With 10 left over. 20 into 100 is 5. So it's going to be 0.55 times by 100, which is then 55%. And we've got our answer. So if you were to ask, what's the probability of picking a child that is not older than 3, it would then be what's left from 55% to 100, which would be 45%. Okay. Now we have done probability tables. One of the most important parts is probability is the following topic, known as combined probability. And combined probability means the likelihood of an event happening more than once. So we calculate probability by multiplying the probabilities together. So for example, the chances of flipping heads on a coin is 0.5. What's the chances of flipping a head twice in a row? So anything to do with more than once or both, we multiply the probabilities together. So here we do 0.5 times 0.5, which is 0.25. And something to remember, your answer will always be smaller than the original probability. because the likelihood of things happening more than once is less than it happening once. So your likelihood will always be less. So let's have a couple of goes at a couple of these questions. Remember, we always multiply the probabilities. So Gary is playing cricket. When attempting to catch a ball, the probability Gary is successful is 3/4 or 3/4. During the game, Gary attempts 2 catches. Find the probability Gary is successful with both catches. So here we know the probability is 3/4. So all we're going to do is, because it's both catches, so it's 2, we're going to do 3/4 times 3/4. And we're multiplying fractions, we go across the top and across the bottom. So 3 times 3 is 9, 4 times 4 is 16, and we've got our answer. Okay, let's try that again. Helen is taking part in a quiz on TV. The probability she answers a question correctly is 4/5. Helen is asking 2 questions. Calculate the probability she answers both questions correctly. So here we've got 4/5 multiplied by 4/5, which gives us 16/20. Now we can simplify to divided by 4, which would be 4/5. Okay. And then finally, Matthew is playing darts. Sorry, that is incorrect. I've done 20, it's 25 actually. Sorry, guys. Just to eradicate that. See, sometimes in the morning we can make mistakes as well. So 5 multiplied by 5 is 25, and that's our fraction. And then Matthew is playing darts. The probability he hits a bullseye is 0.3. Matthew throws 2 darts. Find the probability Matthew hits a bullseye with both darts. Okay, so have a go at this question. Okay, so the probability he throws first dart is 0.3. We're then going to times it by 0.3 because it's both, which gives us 0.09. Now, if that was he throws the dart 3 times, he throws the dart 4 times, he throws the dart 5 times, you'd multiply by the amount of times that event is happening. Often with these questions, it is often just twice. So it's often using the word like both. Okay, our final section of today's lesson is on probability trees. Okay, so as we know, like trees, they have branches, just like probability trees. And these branches always add up equal a whole or 1. So, for example, Hannah is going to play 1 game of chess and 1 game of backgammon. The probability she will win the game of chess is 0.6. So we put the 0.6 next to Hannah wins here. The probability she will win the game of backgammon is 0.7. So we put that here. And it's asking us to complete the probability tree diagram. Okay, what's really important to remember is these branches add up to 1 or a whole. How we view probability trees is that we look at the first outcome, which is that she wins, and then what will happen with the second game. So we read it across. Hannah wins, or Hannah wins and she loses. However, she might start with losing chess, but then she might win backgammon. And then, so we always start here and look at the 2 branches that come off for each one. So if Hannah wins is 0.6, what do we add to 0.6 to make a whole, or 1, which should be 0.4? And then what do we add to 0.7 to make a whole, which would be 0.3? And this stays the same at 0.7, and that becomes 0.3. And we've completed the probability tree diagram. Now, The question says at the bottom, work out the probability Hannah will win both games. So here we do combined probability. And what's really handy if you get in the habit of doing is when you read a question, write out what you think you need to do. And then all you have to do is say multiply. Right, now you know what you're doing. So we'll win both games. So chess is 0.6. Backgammon is 0.7. So we're going to multiply those two together, which leaves us with 0.42. And that is how we do the same outcome twice with probability trees. So you multiply across the probabilities. The second part of probability is different outcomes. And this is where the steps get a little bit more complicated. So what I'm already going to do for you, I'm going to fill in exactly the same tree. And then I'm going to write you some steps about how we complete this question. So the first thing that we do is we write out the outcomes at the bottom of the tree. So step 1, write out the outcomes at side of the tree. Now, if you were doing this on a computer, I would get you to draw out the diagram on your note paper that you can have and then write the outcomes. So what I mean the outcomes after both games. So she will win the first game and win the second. So the outcome will be win-win. Then the second outcome is that she wins chess, but then she loses. So then the next outcome would be win-lose. Then the third outcome is that she loses chess. So she starts by losing chess, but then she wins backgammon. So it would be lose-win. And then the last outcome is she doesn't win either. So it'd be lose-lose. And that is our first step. Step 2 now is that we calculate the probabilities of those outcomes. Do this by multiplying. So for example, our first one for win-win, 0.6 times 0.7 is 0.42. Then to win and then lose would be 0.6 times 0.3, which would be 0.18. Then lose-win would be 0.4 times 0.7, which would be 0.28. And then lose would be 0.4 times 0.3, which would be 0.12. Now this will always add to 1 or a whole. So you know you've done it correctly. Then step 3, we're then going to tick all the outcomes that apply to the question. And our question says, well, Hannah will win at least one of the games. So what you do is you look for all the outcomes with at least one win. Now, if that said lose at least one of the games, you'd look for all the outcomes with at least lose once. All the outcomes with at least one win. So win-win has at least one, so we can tick that. Win-lose has at least one win, and lose-win, but lose-lose doesn't. So then we're left with these 3 probabilities. And then your final step is to add the probabilities you've ticked. Sorry, step 4 is to add probabilities. So here we're going to do 0.4, 0.18 and 0.28. 8 and 8 16s, 8, 4, 2, 6, 8. And our probability that she will win at least one of the games is 0.88. Now, if you added that to the remaining probability that's left, so 0.12 and 88, is then 1. So you know that you have done those steps correctly. Okay, let's now have a go at our final problem question. So a teacher is playing a game with a child. She throws the ball twice and works out how many times a child catches it. Use the probability tree to answer the following question. So our first one is complete the probability tree. So on the first turn they catch, but then they drop. So if it's 2 out of 5 for catch, it's then 3 out of 5 to drop because they add up to 5 out of 5, which is a whole. Then we can just fill that in now. And that is our first step done. Next, we're going to calculate the probability the child catches the ball on the first and second throw. So the first catch is 2/5. To catch it again is 2/5. So we're going to multiply those together and we're left with 4/25. And that's our second part done. Now the third part is where we're going to have to bring in those steps. So calculate the probability the child catches the ball at least once. So we need to write all our outcomes first. So first is catch, then catch. So it'd be catch, catch. Then catch, drop. Then drop, catch. And then drop, drop. And we've done our first step. Then our next step is we're going to multiply our probabilities. So catch, catch is 2/5 times 2/5, which is 4/25. Catch, drop, so 2/5 times 3/5 is 6/25. Catch, drop, catch is 3/5 times 2/5, which is 6/25. And then drop, drop is 3/5 times 3/5, which is 9/25. Okay, we have now done that step. Our next step now is to tick all the ones that apply to the question. So catches the ball at least once. So we're looking for all the outcomes that have the probability of catch at least once. Does catch catch? Yes. Does catch drop have at least one catch? Yes. Does drop catch? Yes. Does drop drop? No. So then our final step is we add the probabilities. So 4/25, add 6/25, add 6/25. With fractions, we only add the top. You keep the bottom the same. So then it's going to be out of 25. 6 and 4 is 10. Add 6 is 16/25. And that is how we do probability trees. So we have now covered expressing probabilities, fractions, decimals, and percentages, calculating probability on a scale, looking at probability tables and probability trees. So now all you need to do is complete the worksheet attached to this, send it to your assessor or tutor, and you've completed probability.